Hi, Mick McQuaid here. I'm in a terminal window. Well, I'm not in a terminal window, but the video is. It looks different from your terminal window because I've done a number of things to customize it. For example, you can see in the upper left-hand corner that I'm using a piece of software called iTerm2, and I'm also using another piece of software called Blesh and another piece of software called Powerline. You don't need to use any of these terminals, any of these softwares. They just make my life easier because I do a lot of work at the command line. If you don't plan to do much at the command line, it may not be worth it for you to spend the time to install these things. So I'm going to download some files. So presumably you've already installed SQLite 3. So I'm going to download some files from Canvas. Our Canvas site has a Files tab, and in the Files tab there is a folder called SQLite Examples. And what I would like you to do is click on the three dots next to it and click on Download. I actually already downloaded this, come to think of it, so I'm not going to click on it again. And what it's going to do is put in my Downloads directory. So I'm going to just change to my Downloads directory. It's going to create a file named Course Files Export in my Download directory, and I can list the files in that zip file, and you can see there are the subfolder SQLite Examples, and underneath there are 5 files. So I'm going to actually unzip it. You can do this from the you can either do this at the command line or you can do this in your file manager. And now I have to change to the SQLite Examples folder, and you can see that the files are there. And since I have SQLite 3 installed, I can just say SQLite 3, and give the name of one of the 3 db files, .db files. And I'm going to give the name of pets, which is a very simple file. Okay, so I say SQLite 3 and a space and then pets.db, and it opens SQLite 3 with the pets.db loaded. So I could say tables, and I see that there's one table in this database. It's called pets, and I can see what's in the pets table by saying select star from pets, followed by a semicolon. And I see that I have 5 pets: a dog, a cat, a parakeet, a python, and a megalodon. And it also tells whether I actually have one of these, I think, is what the yes and no mean. So what we've seen here are 2 kinds of commands. So this is a command that's specific to SQLite. It's called a dot command. And this is an example of SQL. This is an SQL command. And this is the centerpiece of our course, is SQL commands. This is how we get data from a database. Every database management system, whether it's SQLite or MySQL or anything, has some type of built-in commands that are specific to that database, but they all respect SQL commands. They all use SQL with some variations, but in general they all use SQL. Now I can find out a little bit more about this table by saying schema pets. And notice that what it does is displays the SQL command that created this table. Now, there's another way I can look at that command because I created this myself. So I'm going to exit out of SQLite by saying .exit, and I'm going to take a look at where it says petdata.sql. So I'm going to say cat petdata.sql. Oops. And my system has a special version of cat that puts things in color and with italics. Yours will just be probably plain text unless you've actually installed a separate program to do all this colored stuff. And this file, petdata.sql, contains that command that we just looked at, create table pets, and here's the contents of pets. And then the file petdata.sql contains an insert statement that inserts values into the name and kid-friendly. Okay, so it's not whether we have it, it's whether it's a kid-friendly pet. So pythons will, I suppose, eat kids, and megalodons don't exist, but if they did, they would eat everything in sight. Okay, so the pet ID we didn't specify, but it appeared when we looked at the table. There were 5 IDs, 1 through 5, because SQLite automatically, if we say that we have an integer primary key, if we use this language here, it will automatically create that when we insert records into the database. And it will automatically increment that so that no 2 keys are the same. So it will increment it 1, 2, 3, 4, 5, and so on, however many we put in there. So how did I create this? Well, I'm going to recreate it. Well, in fact, actually, let me do this. I'm just going to show you that PetsDB and PetShopDB are have exactly the same size. Because I did it separately, I can create as many databases as I want using these instructions. Petdata.sql are instructions to create a database. So I can say this, SQLite 3, and I'll say another pets DB. And then I put in this greater than sign, a less than sign, and then I put petdata.sql. And notice that it appears as if nothing happens, but if I say LSL again, I'm going to have another file called anotherpets.db, and it has the exact same size as petsdb and petshopdb because the instructions are the same, so it's basically put the same database in there. Now I also want to show you this other database, and this is a much more elaborate database. So let's first look at a diagram of this other database. This is a very commonly used database. I don't know what was going on here, but anyway, this is a commonly used database that is used for instructional purposes. You can see it's up at the SQLite tutorial page. And this kind of diagram is very standard among databases, among all relational databases. It consists of a bunch of rectangles with words in them and lines connecting the tables, and the lines always have some kind of symbols on them that give us an indication of the what kind of relationship exists between these different entities. So this is called an entity relationship diagram, and we'll talk more about this later. We'll look at more entity relationship diagrams. But they're all characterized, they've been in existence for 50 years, and there are different flavors of them, but they're all characterized by these rectangles containing information about the data that's in the table, and lines connecting the tables. So you can see that the titles of the tables, by the way, are media types, genres, playlists, playlist track, tracks, artists, and so on. So now I'm going to open the Chinook database by saying SQLite 3 Chinook DB. This is already created for us. And if I say tables here, I get a fairly long list of tables, including the names that I just rattled off to you. Let's take a look at one. Here's one called albums. So we're going to say select star from albums. And you can see that there are 347 albums, most of which are look like classical music to me, or most of the ones towards the end of the list anyway are classical music. And they also have, so they have numbers identifying them, and they also have another number associated with them. So I'm curious what that other number represents. So I'm going to say schema albums, and it is the artist for the album. So this is a little bit tricky because the artist for albums, a lot of albums are compilation albums that have multiple artists on them. So this is maybe not the best way to design the database. But anyway, we have an album ID, a title, and an artist ID. And you can see here we have the album ID here, 1 through 347, the title, Quana Scotzi, Philip Glass thing, and then a identifier for the artist ID. And this artist ID number probably matches Philip Glass in the, let's take a look at the select star from artists. And yeah, 275 is the last one in the list, and it's the Philip Glass Ensemble. So you may wonder why we've identified Philip Glass as number 275 instead of just writing out Philip Glass in the database. And the fact is that these names might change, but the entities that they represent are pretty stable. So, for example, here's, let's see if I can find a good example here. Okay, here, Otto Klemperer and the Philharmonia Orchestra. So we might instead do it like this, the Berliner Philharmoniker and Herbert von Karajan. And so here the orchestra name is first and the conductor name is second. And we might decide to do that consistently throughout. So you might want to change those, but that isn't going to change what the basic artist is. It's still the same pair, however we phrase it. So we might change these names, but we're not going to change these ID numbers. Probably. Generally. Okay, so we could also say schema. Oh, I didn't say very much about, we're going to learn much more about this stuff later. Let's look at schema artists. And it's pretty simple. It's just the artist ID and the name. And see artist ID and name here. Create table if not exists artists. And all SQL commands. By the way, some people say SQL, some people say SQL, and some people say SQLite, and other people say SQLite. And there are various ways of saying these things, and I don't care. I'll use some of them interchangeably. All SQL commands end with a semicolon, but the commands to SQLite, here I'll do the help command, don't end with a semicolon. The dot commands don't end with a semicolon. And that's often a matter of some confusion. So let's say I say select star from, I think there's an invoice one here, isn't there? Invoices. select star from invoices. And let's say I forget to put the semicolon. This is a SQL command. And I forget to put the semicolon, and so it gives me a continuation line. So it reminds me, in a sense, that I have forgotten to put something in. I could also say some more complicated stuff, but in this case I'm just going to put the semicolon, and it gives me the information. And the information contains, I guess, probably an invoice ID, a customer ID, and whatever they spent, which sometimes isn't very much. And these tend to be real addresses. I looked at this table before, and I've lived in some of the cities that are listed here, like New York and Tucson, and I've visited Dublin, and I've lived in Madison, and so I know that these streets actually exist. So, and of course, when we looked at the artist table, we saw that the artists actually exist, although I think this was created about 15 years ago. So there are no current, well, there's Amy Winehouse, but obviously from before she passed away. House of Pain. So it's not all classical music, but it's not very current because the thing was created 15 or 20 years ago. Okay, so that's all I want to say about SQLite right now. We're going to deal with it in the middle of the course. We're gonna actually use it, and you're gonna do some exercises with it. But this just gives you an idea of what it's all about. I'm just gonna say exit now and leave the SQLite database shell. And that's it for now. Thank you for your attention. Bye.